Hello and welcome to a new video from Built with Rafiq. Today, I will show you how to run an AI-based facial recognition using Intel's Neural Compute Stick 2 hosted on a Raspberry Pi 3B+. Before I start with the tutorial, let me show you what the project will look like. The Intel Neural Compute Stick 2 NCS2 is a neural compute engine that can run deep neural network applications on device without the need for cloud compute resources. In this demo, the NCS2 runs a neural network to detect a human face, additionally estimating the age, gender, and emotions. Let's start by showing all the products that will be used in this tutorial. The main component is the Neural Compute Stick 2 previously mentioned. It is a USB plug-and-play artificial intelligence device for deep learning inference at the network edge. Intel NCS2 is built on the Intel Movidius Myriad X VPU or Vision Processing Unit, featuring 16 programmable shave cores and a dedicated neural compute engine for hardware acceleration of deep neural network inferences. The Neural Compute Stick supports the OpenVINO Toolkit, a software development kit to optimize performance, integrate deep learning inference, and run deep neural networks on the Movidius Vision Processing Units. To host the Neural Compute Stick 2, I will use a Raspberry Pi 3 Model B+. I will also need a micro SD card flashed with the Raspbian Stretch OS. I'll show you how to do this in the next step. Now, before you connect the micro SD card, you will need to flash it with Raspbian Stretch. From a browser, navigate to the Raspberry Pi download repository and choose the last updated Stretch version. You'll see it has the name 2019-0408. Click and download the zip folder. After the download is complete, I'll open the Etcher software, which I will use to write the Raspbian OS to the micro SD card. Click on Flash from File and select the downloaded zip folder. Then choose the micro SD card and finally click on Flash. This will take a couple of minutes. When it's complete, eject the micro SD card and plug it into the Raspberry Pi. I will also connect an HDMI cable, an Ethernet cable, a keyboard, and a mouse. You will also need a webcam, or you can use the official Raspberry Pi camera. Lastly, connect a 5-volt power supply with a micro USB end. Make sure the power supply has an output current of 2.5 amps. The Raspberry Pi will now boot up. Do not plug in the NCS2 stick yet. We will need to install the OpenVINO toolkit first. Complete the boot process of your Raspberry Pi. I will skip that and will jump right into installing the OpenVINO toolkit. Open a new terminal window, run the sudo update and sudo upgrade command, and then install CMake. Next, I'll create a new directory and will call it OpenVINO. To download the OpenVINO toolkit, navigate to the Intel open source webpage. The folder we need is under OpenVINO Toolkit /2018 R5/packages. Using the wget command, I will download the tar folder in the OpenVINO directory and untar the package. Now, I will set up the environment variables. Using the set command, I will add the setup var script to my installation directory. Now I will run it to set up the variables. You will get the message that the OpenVINO environment has been initialized. We will need to add the current Linux user to the users group. Now I will log out and log in for these changes to take effect. After logging back in, you'll have to run the setupvars.sh script again. To perform inference on the neural compute stick, we'll need to install the USB rules running the install ncs udef rules.sh script. Plug the Intel Neural Compute Stick 2 into the Raspberry Pi. Now everything is set to run an application on the NCS2. In this demo, we'll run the interactive face detection demo that is offered with the toolkit. Navigate to the samples directory, create a new build directory, and change directory to it. Now we will build the interactive face detection demo. First, we will run the cmake command, then the make command. The sample is built under ARM v7l/release, where I will navigate. We will need now to get the pre-trained face detection models, which are also on the Intel open source page. I will download the XML and bin files. I will download them in the same directory where my interactive face detection application is built. Now we're ready to run the sample. Type in ./interactive face detection demo -h and hit enter. Here you can see all the options to run the sample. Let's run it using the pre-trained face detection model we downloaded. The input model will be the face detection.xml file. The device is the Myriad, the NCS VPU, and the input will be from the webcam. As you can see here, my face is detected and it's working nice and very smoothly. To make it more fun, let's add the pre-trained age, gender, and emotion recognition models and run it. The emotion recognition is working pretty accurately, but the age recognition model has an average error of ±7 years, as stated on the OpenVINO Toolkit website. To test the demo more, I let some of the Mouser team to play with it. I hope this tutorial showed you how easy it is to get started with the Intel Neural Compute Stick 2 and the OpenVINO Toolkit running on a Raspberry Pi. For more information, visit Mouser.com.